Hello everyone. For the given circuit, find current in 6 ohm resistor by using nodal analysis. So for nodal analysis, first we define nodes in the circuit. If you see this circuit, there are total 4 nodes, that is node A, node B, and node C, and our fourth node is D. Now we have to assume one node as a reference node. If you see this circuit, in this circuit, there is a 12-volt voltage source connected between two nodes. So here, if you select D node as a reference node, then we have three unknown node voltages A, B, and C, and our circuit solution will be lengthier if you select node D as a reference node or node A as a reference node. Now our next option is if you select node B or node C, any of one node as a reference node, so the solution will be much easier. And if you select node C as a reference node, then the solution will be very simple. So for selecting any of one node as a reference node from B to B or C, so you will get other node voltage values by using this 12-volt voltage source. So let's discuss. So here, if you select node C as a reference node, so this is at 0 volt. So other node voltages we can assume node A is at V1, node B is V2, and node D is V3, and node C is already we are assuming at 0 volt. Now define branch currents. So at node 1 or node A, branch currents are I1, I2, and I3. Node B, branch current is I2, I4, and I5. Add node C, I3 and I5 is defined, and our branch current is I6, I4, I5, and I3. So here, if you see this voltage source, 12 volt, assuming branch current is I5, this is VB, this is VC, this is at plus, this is minus. So here you can write the equation VB plus 12 according to current direction minus VC is equals to 0. Here VB is assuming V2 plus 12 minus VC is assuming 0 is equals to 0. So here we get V2 is equals to minus 12 volt. So if you see this circuit, in this circuit, we have to find current in 6 ohm resistor, and one node voltage is already calculated V2. So here we can apply KCL at node A and node D. So first we apply KCL at node D. It will give solution in one step. So apply KCL at node D. At node D, I4 is incoming current and I6 is incoming current and I1 is our outgoing current. Now, if you see the values, I1 is equals to minus 2 ampere according to current direction. And if you see the value of I4 is V2 minus V3 divided by 2, and our I6 is 0 minus V3 divided by 6 ohm. So here we can put all these values. I4 is V2 minus V3 divided by 2 plus I6 is 0 minus V3 divided by 6, and I1 is minus 2 ampere. Take LCM, that is 3V2 minus 3V3 minus V3 is equals to minus 2. Here you can write 3V2 minus 4V3 is equals to minus 12. Here you know the V2 is equals to minus 12 volt, that is minus 3 into 12 minus 4, 3. V3 is equals to minus 12. So here 36 minus 36 plus 12 is equals to 4V3. So you can say 4V3 is equal to minus 24. Now here you can find V3 is equals to minus 6 volt. So for finding current in 6 ohm resistor, you have to calculate V3. So here current in 6 ohm, that is I6, is equals to 0 minus V3 divided by 6, that is 0 minus V3 is minus 6 divided by 6. So current in 6 ohm resistor is 1 ampere. This is our answer. So here you see the circuit solution will become more simpler if you select this node as a reference node. And if you select node D or node A as a reference node, then there the solution will become lengthier, and you solve all the equations, then you will get the answer. So this is the concept for assuming reference voltage in a particular circuit. Thank you for watching the concept. Please like and subscribe my channel.